Hello to you all. That's my first tutorial of the series Engineering Studies. Whatever discipline you belong to, the topic for today and upcoming 3 episodes will be very important. So, today let's talk about gradient of a scalar field. If P is a scalar function of three of space coordinates L1, L2 and L3, say then grad P is defined as the vector. It acts on a scalar quantity and it delivers a vector quantity that represents the maximum space rate of increase of of the scalar field. So the figure here showing two surfaces on which the magnitude of V is constant, having the value V1 and V1 plus dV, that is slightly bigger than V1 respectively. Considering 2 points P1 on V1 and P2 on the surface that has the value V1 plus dV along the normal vector dn, and P3 here is another point close to P2 along another vector dl, and obviously dl is not equal to dn. Now that's the scalar field having three space coordinates L1, L2 and L3. Now dV by dl can be written as dV by dn into dn by dl. Here cross multiplication will retain the expression. So now from the figure we see that by simple trigonometry dn by dl turns out to be cos alpha, and as we all have gone through dot products, cos alpha can be written as cap n dot cap l. Here cap n is the unit vector along dn vector and cap l is the unit vector along dl vector. So now by definition dp by dl becomes nabla v. What's nabla? I will get to that shortly. And nabla v is the dv by dl becomes the dot product between nabla v and l cap. Thereby dv becomes nabla v into vector dl, and that's our equation number 1. I have just confined it within a green box. So now from calculus we all know dv can be written in terms of the space coordinates of the coordinate system under consideration. So here L1, L2 and L3 are three space coordinates of the coordinate system under consideration. So if we choose Cartesian coordinate system, here L1 will be x, L2 will be y and L3 will be z. So in Cartesian coordinate system dv can be written as it will be g, and in Cartesian coordinate system dv can be written as del v by del x multiplied by dx plus del v by del y multiplied by dy plus del v by del z multiplied by dz. From the idea of dot product we can write this expression just like this. Here x cap, y cap and g cap are the three unit vectors acting along the three axes of a Cartesian coordinate system, and cap x dx plus cap y dy plus cap z dz is the differential length in Cartesian coordinate system. Dot product of this line will bring us the previous line. So from this we have got another expression for dv. So I am enclosing it within a green box and marking this equation as equation number 2. Now comparing equation number 1 and 2. So let's get back to the equation number 1. Here is it. Yeah, here it is, the equation number 1. So comparing equation number 1 and equation number 2, we get the expression for nabla v. Here nabla v becomes del v by del x into cap x plus del v by del y into cap y plus del v by del z into cap z. So that's actually it, and from this line we get the expression of nabla in Cartesian coordinate system. So here goes the expression of nabla in Cartesian coordinate system. That's just like this. So now what will be the topic for the next episode? Here I talked about gradient in Cartesian coordinate system. What if the coordinate system is cylindrical or spherical? A general equation is just like this. I am giving it here, and for detailed analysis, advanced welcome to the upcoming episode of engineering studies. As I publish tutorials on varied topics like college physics, math, chemistry, advanced science, and engineering, make sure what episodes actually make sure you are watching the category you need actually. So thanks, feel free to comment and share, and don't forget to subscribe. It's important to make sure you are not missing any of the upcoming episodes. And just a bit of the general form. Here U1, U2 and U3 are the coordinates, and H1, H2 and H3 are the metric conversion coefficients that differs from coordinate system to coordinate system. So thank you guys, have fun, and advanced welcome for the next episode. So goodbye.